Now in this one, we've got one species that's being both oxidized and reduced in this redox reaction. ClO2 is in under basic conditions forming both the chlorate and chloride ions in aqueous solution. Assigning oxidation numbers, we see that the chlorine is being both oxidized to a +5 state and reduced to a -1 state. So I'm starting the video here, recording of the video a little bit late in the progress, but nonetheless. So this is the oxidation half reaction, and over on the other side we have the reduction half reaction. Going back to the oxidation half reaction, we balance all atoms except O and H. The chlorines are already balanced. We balance the oxygen in the next step by adding 1 to this side in the form of water. Having done that, that has introduced 2 hydrogens, and so I add my 2 hydrogens over here. It's in the form of H+. It's a basic medium, not acidic, so I have to account for that by adding the same number as 2, the same number of hydroxide ions to each side, and then tidying up a bit because 2H+ and 2OH- is 2H2O. Okay, so that's where I get this. Without the electron, but so without the electron, don't look at the electron yet, I had a charge on the left of -2, and on the right I had -1, so I did need to add 1 electron. Okay? On the other side, I had ClO2 going to Cl-, the chlorines are already balanced. I needed 2 oxygens on the right, so I added those as 2H2O. Doing that, I've imbalanced the hydrogen by 4, so I need 4H+ on the left. And since it is in a basic medium, I add the same number of hydroxide ions to both sides. And over here, this became, again, don't look at the number of electrons yet, that became 4 waters, plus ClO2 goes to chloride, plus 2 water and 4 hydroxide. The charge was 0 on the left, -5 on the right, so I did need 5 electrons. Okay, so now I'm at the stage where I'm balancing the transfer and adding. Okay. So we have 10 OH- plus 5 H2O plus 5 ClO2 plus, going to the other side, it's multiplied by a 1. Oh, I have the hiccups, excuse me. 5 electrons plus 4 H2O plus ClO2. Now the arrow. Back here, multiplying 5 ClO3- plus 10 water plus 5 electrons. Now over here, plus Cl-, 2H2O, and 4 OH-. Okay, whoops, I have to tidy that up a bit. Sorry. Well, can actually get rid of that part. And just tidy this up, like so. Let's capture the electrons, coming and going. Hydroxides, I have 10 and 4, so let's get rid of these. and change this to a 6. I have 5 water and 4 water, and on this side I have 10 and 2 is 12. So I have 9 over here and 12. So these will all go, and this will be left with 3. And oh yeah, I have a 5 ClO2 and this ClO2, and that's because I had the same species being both reduced and oxidized, so that's why it's appearing twice on the left. So we'll just add those together. I think we're ready to write the net equation. 6 OH minus aqueous plus 5 ClO2 plus this one, that's a 6. And nothing, nothing, nothing. That's actually the whole thing on the left. And then on the right I have 5 ClO3 minus, 3 waters, and a chloride ion. Okay, let's check. The charges, minus 6 on the left, minus 5 plus a minus 1, minus 6 on the right. Charges are balanced. 6 chlorine here, and then 5 and 1 is 6 chlorine over here. Oxygens, 6, and then 2 6s are 12, so 12 and 6 is 18. 3 5s are 15, plus 3 more, that's 18. 6 hydrogens, 3 times 2 is 6 hydrogens. It's all balanced.